Thank you for clicking into this video. So in this video, Team DIGITHUB will be sharing about the project, which is the Python calculator with object-oriented programming implementation for the subject Concept and Paradigma. The team members for DIGITHUB are Chong Kar Min, Tracy, Liaw, and Low Wei Jie. In this video, we will be going to be talking about the introduction, the objective and scope, the demonstration and system development, and finally the conclusion. My name is Tracy Liaw with matrix number 27944, and I'll be starting off with project introduction. So what is object-oriented programming? Object-oriented programming, also known as the OOP, serves as a programming paradigm dedicated to structuring code in a manner that mirrors real-world entities such as objects, attributes, and behaviors. The primary objective of OOP is to minimize code complexity and redundancy by encapsulating functionalities within classes, fostering modularity and reusability. So why Python? Python, known for its readability and simplicity, is an ideal language for beginners. Python is multi-paradigm, in which it supports both procedural and object-oriented programming paradigms, providing flexibilities for developers to choose the approach that best suits their needs. The syntax is clear and concise, making it easier to implement and understand the OOP principle. In short, the developed Python calculator should be able to exhibit the implementation of OOP concepts as well as provide problem-solving abilities and at the same time induce interesting user engagement. The next section is the project objective. There are 3 objectives in total, including 1. To develop a functional calculator that can be used to perform basic arithmetic. 2. To implement an interactive and visually appealing GUI for calculator. And finally, to incorporate OOP in creating a modular and extensible code base. The Python calculator also has 3 project scopes, including 1. To serve as a reliable tool for users who are in need for a tool to complete basic mathematical computations. 2. To integrate OOP principles into the development process. And finally 3. Limited to development of a desktop-based calculator application using Python. Now I'll be continuing on with the demonstration of our system. This is the GUI, or also known as the graphical user interface for the Python calculator developed. The calculator includes all 10 indicators from 0 to 9. The currently available arithmetic operations includes addition, subtraction, multiplication, and division. There are also hovering effects on buttons for user interactions. The calculator is able to perform a single or combination of arithmetic operation without confusion of its operation priority. Any unclear commands will also lead to an error message to prompt the users for new arithmetic commands. So that's all for the demonstration of the Python calculator. So that's all for the project introduction, objectives, scope, and also the demonstration of the project. Now I'll be leaving the brief explanation of coding to our other team members of DIGITHUB.
Good day, Doctor. My name is Chong Kar Min, number matric 287173. I will now continue our presentation with a brief explanation of the coding for our system, which is a Python calculator. So, this is the Python code of our calculator. Firstly, we import the tkinter library for creating the graphical user interface for our calculator, as well as the ABC and abstract methods from the ABC model that stand for abstract base class to define the abstract classes and method. Next, we establish an abstract class named abstract calculator featuring an abstract method named calculate. Then, a concrete class named calculator operations is created, implementing the calculate method from the abstract class. This class will utilize the eval functions to execute the basic arithmetic calculations and handles the abstraction by returning error if an abstraction occurs. Following that, we craft the custom buttons class, extending tkinter button class and introducing the hover effects. This class defines the method to manage the mouse enter and leave events, altering the button's background. Moving forward, the calculator UI class is designed to oversee the graphical user interface of the calculator. It will create the display entry widget, define the button layout, and create buttons based on the button layout. It encompasses several methods for button creations, handling the button clicks, executing the calculations, and managing the display entry. Then for this method, it will clear the display entry, handle the button clicks, and update the display entry. And for this method, you will clear any previous error message first. Then, for this one is we'll clear any error message in the display entry and update any message in the display entry. So lastly, we initiate the main window using thinter root and instance of calculator operations for executing the calculations. We initialize an instance of calculator UI with the main window and the calculator instance, initiating the thinter event loop with the root main loop. Now, I will start with the first OOP utilization in our system development, which is class design and implementations. So, what is a class? A class is a blueprint to create an object. Class design involves organizing and structuring the classes in a system to achieve a clear and logical representation of the entities within that system. It focuses on defining the classes, their attributes, and their relationships, promoting a modular and organized code base. In our group, we craft 4 essential classes, which are abstract calculator, calculator operations, custom buttons, and calculator UI. The abstract calculator class serves as an abstract base class, providing a common structure. It features a single abstract method named calculate. Next, the calculator operations takes the abstract calculator as a foundation and implements the calculate method. Here, we leverage the evil functions to perform the basic arithmetic calculations, providing a concrete implementation of the abstract behavior. Moving on the custom button class, it attends the thinter button class, introducing the custom functionality for the button appearance on hover. Lastly, the calculator UI class takes charge on managing the graphical user interface of our calculator. It includes the creation of an interactive calculator with buttons and the entry widget for display. The init function within the custom button and the calculator UI is crucial for initializing the attributes and setting up the initial state of the instances created from this class. In short, our approach to class design and implementation facilitates a modular, organized, and extensible structure, allowing us to build a robust and user-friendly calculator application. After that, I will start with the second OOP utilization in our system development, which is encapsulation and abstraction. What is encapsulation and abstraction? Encapsulation bundles the data and methods together in a class, forming a single unit. It keeps certain parts private, promoting the data protection. On the other hand, abstraction simplifies the complex system by focusing on the essential properties and behavior, hiding the unnecessary details. Encapsulation shines here because each class does a specific job and keeps the word neatly packed within itself. For instance, calculator operations class handles just the calculations. Custom button class focuses only on the buttons, and the calculator UI class deals with the user interface. Abstraction, on the other hand, helps keep the things clear. The abstract calculator class is like the main idea of a calculator, leaving the specific details to the other classes. This makes our system flexible. We can easily switch or add new features without messing up the whole system. In summary, encapsulation and abstraction makes our code clean and adaptable. Each part does its job without interfering with the others, making our Python calculator a reliable and flexible tool. Lastly, the third OOP utilization in our system development is inheritance. Inheritance is a principle that lets a new subclass, which is the child class, inherit properties and behaviors from an existing superclass, which is the parent class. It's like passing down the features from one generation to another, promoting code reuse and creating a hierarchy of classes for easy extension. In our project, inheritance is working in 2 phases. The first one is calculator operations. The calculator operation class inherits from the abstract calculator class. It assures that our calculator operations are structured as defined by the abstract class. The next one is custom button class. The custom button class uses the super function to inherit from the thinter button class. This means that the custom button will get all the good stuff from the button class and can also add or change the things to suit with our needs. In summary, inheritance makes our code more flexible and adaptable, ready to grow with new features in the future. That's all from me. Thank you. I will pass it to next presenter.
Good day, Doctor. My name is Low Wei Jie with matrix number 28969. Next one, I will continue with the polymorphism and interface part. Polymorphism is a fundamental concept in object-oriented programming. It refers to the ability of different object or data types to respond to the same method, function, or operator through method overriding or method overloading. An interface in programming is a contract specifying a set of methods that a class implementing the interface must provide, define a blueprint for the structure and behavior of objects. In our calculator system, the polymorphism technique applies in the calculate methods. Calculator operation class provide a specific implementation of the calculate method while adhering to the abstract definition in the abstract calculator class. Moreover, we implement the graphical user interface in the system. The interface is created using the Tinder library provided by Python. The GUI components like buttons, menu, and windows are defined using the interface that specify the methods and properties that GUI element must have, allowing us to create customized user interface while adhering to the common set of rules and behaviors. The interface technique is applied in the calculator UI class to build and manage the user interface elements, handling different user interaction and display the result of calculation. Moving on to the solid principle. The solid principle consists of 5 principles which represented by each letter in the words solids. The principles is important in creating more maintainable and flexible software system for object-oriented programming and software engineering. In our system, we apply 3 out of the 5 principles, and the first one is single responsibility principle. This principle suggests that each class should only conduct single job. In our system, all the classes are built based on this principle. For example, the custom button class will only handle the button appearance and behavior, while the calculator operation only managed for the calculation parts. Next, open-close principle, which encourages a system to be open for extension but closed for modification. In the custom button class, it allows the developer for adding new features without altering the original codes. Last but not least, the dependency inversion principle. It emphasizes that the abstraction should not rely on implementation details. Instead, it should be the inverted way. Details should rely on the abstraction. In the calculator system, the code relies significantly on the abstraction, especially evident in the interaction with the abstract calculator interface. This not only facilitates the introduction of the new calculator implementation adhering to the same interface, but also enhances the ability to change in the future. Next part is about the user interaction. The user interaction refers to how a user can engage with a system or application. It involves the design and implementation of the features which allow the user to interact with the software by performing various functions like clicking, inputting, and scrolling. In the calculator UI class, the GUI components such as button and the display entries are created to allow for user input and feedback. The button click methods and calculate handle user interaction, updating the display and perform the calculation based on the user input. For the custom button class, it will even change the background color when the mouse hovers over them, which is a very attractive interaction event. In conclusion, this Python calculator project effectively demonstrates the power of object-oriented programming in creating a flexible and modular system. It showcases how object-oriented programming principles such as class design, encapsulation, abstraction, inheritance, polymorphism, the solid principles, and the user interaction can leverage and build an efficient calculator capable of handling various mathematical operations. The emphasis on organized and reusable code highlights the importance of this principle in software development, enabling ease and maintenance and scalability while reduce the redundancy and development time. As technology evolves, the lesson learned from this project remain relevant, emphasizing the enduring significance of object-oriented programming in modern software development for building a scalable, maintainable, and efficient system. So that's all for our presentation. We hope Doctor enjoyed it. Thank you and see you next time.